A very good day to all my beloved doctor. We are from Group 10. For the Manova project, our topics is on the factors affecting the distance traveled by the ball and the angle of the ball path. I will explain on the abstract and introduction. In the practice, to study the relationship between the independent and dependent variables, the multivariate analysis of variance Manova is used to assess whether there are any discrepancy on more than one continuous dependent variables among the independent group. To enhance the understanding of Manova, an experiment on the factors affecting the distance traveled by the ball and the angle of ball path is carried out. In this experiment, the independent variables are the type of the ball, speed of fence, and the type of surface, while the dependent variables are the distance traveled by the ball and the angle of the ball path. The pattern of the distance traveled by the ball and its angle of the path is observed by varying these independent variables to several levels. There are 3 levels for each factor. For the factors on the type of ball, we use ping pong ball, marbles, and kickballs, while for the factors on the speed of fan, the speed of fan is set at level 1, 2, and 3. Meanwhile, for the type of surface, the cement floor, tar floor, and road are examined. The control variables in our experiment is the surrounding wind speed. In this project, SPSS software and MATLAB are chosen to do the Manova analysis. For the introduction, Manova is one of the most popular multivariate statistical technique in the study of social science. It is practically different from ANOVA, although they do share the same basis. In a simple definition, Manova is the generalization of univariate ANOVA in many variations. Manova is better than ANOVA because it allows taking a combination of dependent variables into account instead of just a single one. In Manova, the dependence variables are known as factors. One of the main applications of Manova is multivariate comparison testing, where parameters for different levels of factors are examined to be significantly different or not. In a simple way to understand, Manova is used to compare the data of random variable whose value is unknown. So there are many software that can be used to do the Manova analysis, such as the R programming, SAS, and SPSS. In our project, SPSS is chosen because it allows many different types of analysis, data transformations, and forms of output. In short, it can adequately serve our purpose. Basically, the SPSS works by first storing and organizing the data, and then compiling the data set to generate appropriate output. So it is designed in such a way that it can handle a large set of variable data format. That's why we choose SPSS to do the Manova analysis.
The objectives of our Manova project is the first one is to investigate the distance travel of the balls and the angle of the ball path. The second objective is to determine whether mass of ball has effects on the distance travel and the angle. Then our last objective of this project is to analyze the distance traveled by the ball and the angle using different forces. Then we go to the methodology of the protocol of this project. First, we place the ping pong ball on the cement floor. We mark the initial position of the ping pong ball with a marker pen. Then we blow the ping pong ball with a fan with the speed of number 1. Then we mark the final position of the ping pong ball. We measure the distance that I got it. Then we measure the angle of the ball from its starting point using a protractor. Then we repeat step 1 to step 4 by blowing the ping pong ball on different surfaces on the road and on the tile floor. Then we repeat step 1 to step 5 4 times to get more accurate results. Then we repeat the experiment by changing the speed of fan to number 2 and number 3. And throughout the experiment, we use 3 different surfaces: the cement floor, the road, and the tile surface. Then we repeat the experiment by replacing the ping pong ball with marbles and kids ball. We use the different speed of fan and the different surfaces. The cement floor, the road, and the tile floor. That's all for the protocol.
Okay, so this is the result that we get after we do the experiment, which is our response variable is distance traveled by the ball and angle of the path of ball. Okay, here we have three types of ball, which is ping pong ball, marbles, and kickball. Okay, so each type of ball we do 3 speed of fan, which is 1, 2, 3. And then each speed of fan we do on 3 type of surface, which is cement floor, road, and tile surface. Okay, as we can see here, this is the table for angle of the path of the ball, which is we measure in degree. And this is the data that we get after we measure the distance, which is in cm. Okay, so this is the result for marbles and this is the result for kickballs. Okay, next we go to the Manova analysis. Actually, in Manova analysis, we get more than this, but here we just do for the mean value and for the standard deviation. Okay, so here have 4 parts, which is mean value for angle path of the ball, standard deviation for angle path of the ball, and the others 2 is mean value and standard deviation for distance traveled of the ball. Okay, here the highest value is 111.25, and for the standard deviation, the higher value here is 28.9663. Okay, so next the higher mean value here is 244.50, and the standard deviation here, the higher value here is 157.12. Okay, so next the marbles, we do on the marbles. Okay, so the higher mean value for angle path of the ball here is 148.75, which is the experiment we do on the tile surface. Speed of fan is 2. Next, we go to the standard deviation for angle path of the ball. The higher value is 21.985. We do the experiment on tile surface. On the speed of fan is 3. And then the mean value for distance traveled, the higher is 1 to 0.75. We do the experiment on the cement floor. The speed of fan is 3. And next we do for the standard deviation here, the higher value is 13.736, which is the type of surface is tiles and speed of fan is 1. Okay, lastly on the kickballs. On the kickballs, the higher value means here for angle path of the ball is 147.50. For the standard deviation is 27.801. Okay, next we do on the distance travel. The mean value that we get here, the higher value is 352.25. Okay, lastly, the standard deviation for distance traveled the ball, the higher value is 32.786. Okay, thank you.
Moving on to the second part of the data analysis, besides descriptive analysis, we also did a graph analysis. So now let us look at the first dependent variable of our experiment, which is the angle of path traveled by the ball. So as you can see, there are 3 graphs here in the slide. So this graph is the estimated marginal means of angle of path for different speed of fan. If you look into one of the graph, there are 3 types of lines plotted with different colors. So the green color represents the tiles, and the blue color represents the road, and the red color represents the cement floor. So this graph is the estimated marginal means of angle of path at different speed of fan for different types of ball at different types of surface. So this is for the first dependent variable. Now move on to the second dependent variable, is the distance traveled by the ball. So the graph is still the same, which is the estimated marginal means of distance traveled at different speed of fan for different type of ball at different types of surface. So this is the graph analysis. Now let's move on to the third analysis that we obtained from the SPS software, which is the regression analysis. Regression analysis is the analysis for where a set of method that is used to estimate the relationship between a dependent variable with one or more dependent variable. The common regression analysis is linear and multilinear. And one important thing to mention here is the regression analysis cannot be done directly on Manova, which is the multivariate analysis of variance, because Manova contains one or more dependent variable with one or more independent variable. But for regression analysis, we can only estimate the relationship between one dependent variable with one or more independent variable. So from the regression analysis, we can obtain three important tables which gives us different informations about the model of the data. So for our first dependent variable, which is the distance traveled by the ball, so we'll look into the model summary first. So the model summary gives us the value of r squared. So the r squared is the percentage variability of the dependent variable. So in our case, the r squared value is 0.178, where if we convert it into percentage, we will get about 17.8%. So the higher the r squared, the better the model fits the data. So in our case, the model fits modesty. So the model can fit the data good, modesty, or poorly. For in our case, the model fits modesty. Or in other words, I can say the model is not all that good because there are a lot more individual variables that can influence the responding variable, which is not in the list. So there are many other factors that can also affect the distance traveled by the ball. So now moving on to the second table, which is the ANOVA table. So this ANOVA table gives us the F-test or significant, which determine the model is good or not. As I mentioned earlier, we can't do Manova analysis because we have Manova has more than one dependent variable. Only ANOVA analysis can be done because ANOVA requires a dependent variable. So from the ANOVA table, we look into the p-value. So this p-value is compared to the alpha level, which is 0.05. So if the model is said to be significant if the p-value is less than 0.05. So for our dependent variable, for our case, the significant is 0.00137, which is less than 0.07. So it is said to be significant. So now let us move on to the third table, which is the coefficients table. The first two tables, which is the model summary and ANOVA, look into the independent variable as a set. The independent variable is taken as a set or group. But for a coefficient table looks at each of the independent variable individually. They analyze whether each of the independent variable is significant or not. So now from the coefficient table, we can summarize that the type of ball is not significant because the p-value is about 0.167, which is higher than 0.05, but the type of surface is 0.00. We can only see 0.00 because I already simplified. I already rounded off to 3 decimal places. So actually there's a number behind that, but still it is smaller than 0.05, which explains that the type of surface is a significant independent variable. And the third one is the speed of the fan. So the speed of the fan also not significant because the p-value is higher than 0.05. So now let's look at the second dependent variable, which is the angle of path of the ball. So for the model summary, we look into the r squared value. So the r squared value that we obtain here is about 0.534. If you convert to percentage, it will give about 53.4. So this percentage or this r squared value is far better, which explains the model fits the data quite good compared to the distance traveled by the ball. So now let us look into the ANOVA table. So for the ANOVA table, we look at the significant to see whether the data is significant or not. So the significant value or the p-value is also very small, or compared to the alpha level, it is very less or almost near to 0. So this explains that the data is also significant, or the model is also significant. So now let us look at the last table, which is the coefficient table, where we will see the independent variables individually. So for the type of the ball, we get a p-value of 0.00, or which is smaller than 0.05. That explains that the type of ball is a significant independent variable. The second one, which is type of surface, gives about 0.25. 0.25 is higher than 0.05, which explains the type of surface is not a significant independent variable. And the last one is the speed of the fan. The speed of the fan has a p-value of 0.00, which is less than 0.05. And the speed of fan is also a significant independent variable. If we look into the overall analysis, regression analysis for the angle of the path, this is quite good compared to the distance traveled by the ball, where the r squared value is also higher, and the significant is also almost 0 or very less, and the significant and there are 2 significant independent variable. So that's all for the regression analysis part.
So for conclusion, in conclusion, the distance traveled by the ball and the angle of the ball path depends on the mass of ball, speed of fan, and the surface roughness. The greater the mass of the ball, the smaller the distance is traveled, and the greater the speed of the fans, the greater the distance traveled by the ball. Next, it's observed that as the surface roughness increases, the distance traveled by the ball decreases. On the other hand, the smaller the mass of ball, the greater the angle of its path, while the greater the speed of fan. The greater the angle, there are some errors in the experiment, as the surrounding wind speeds may affect experimental results. So that's for the conclusions in my part.